Hi everyone, and welcome back once again. Today I'm going to show you how to prove trig identities. Probably you've seen this kind of funky statements or mathematical formulas, and you always wonder, how can I prove this? They say prove these identities, but you don't even understand them. Don't worry. Today I'm going to share with you tips and tricks that will help you prove every trig identity out there. And if you follow me, we're going to go from beginner to advanced, and you would master the art of proving trig identities. When I started learning about this newly, I was also confused, but I had to work hard and figure it out on my own. Now I'm going to share with you the tricks I learned by myself, and this has been working for every other person I have been in contact with. The people I have been teaching how to work this out, they can also testify that it works for them. Now, how do we prove trig identities? Well, before we begin, I need you to understand that the concept of proving trig identities is just for you to show that the left-hand side is equal to the right-hand side. That is the first thing that you need to know. If you are starting from the right, you have to show that you can find the right side in here. So if you begin with the right, you should end up with this solution here. And if you begin with the left, you should end up with the right. So to show that both sides are equal. And this is what happens in every trig identity problem. Now that's the first thing that you need to know. The second thing you have to know is that you need to memorize what we call some identities actually. So here are a few of them I'm going to share with you today. There are actually three fundamental identities you need to memorize as a learner. And the first one is called Pythagorean identities. You need to know these ones by heart. The first one is, if you have sine squared x plus cos squared x, it is always equal to 1. Always. So whenever you are proving an identity and you come across this, please, you can replace this thing here, or this statement on the left, with a 1. It's going to work. Okay? Now that's the first thing you need to know. Secondly, we also have that 1 plus tan squared x is equal to secant squared x. You need to also memorize this. Okay? Now the third one is 1 plus cotangent squared x is equal to cosecant squared x. You also need to memorize these Pythagorean identities because they are going to be very crucial whenever you are solving problems related to proving trig identities. These are called Pythagorean identities, and you have to memorize them. The second set of identities you need to memorize is, or are, what we call reciprocal identities. There are about 6 of them here, and you need to memorize them one by one. This one says if you have sine x, it is equal to 1 over cosecant x. If you have cos x, it is equal to 1 over secant x. If you have tan x, it is equal to 1 over cotangent x. If you've got cosecant x is equal to 1 over sine x. So these are just the equivalents, right? If you replace one with the other, you will still arrive at the same answer, provided you know how to manipulate the algebra. It's just going to work. All right, so these are the second set of identities you must memorize. It's very important that you memorize them because they're not just going to flow like that. You must memorize them and understand them. Now, for today, this is where we're going to end, right? Because there are a lot of them, but we have to just talk about Pythagorean, reciprocal, and quotient. So this one right here is your quotient. Whenever you have tan x, it's equal to sine x over cos x. Okay? So if you whenever you see tan x, please, it's always good to replace it with this. It's going to work. Okay? And if you have cotangent x, replace it with cos x over sine x. It's always going to work. Okay? So you have to memorize all these identities. In our next video, we shall be talking about sum and difference formulas, double angle formulas, half angle formulas, sum to product, and tangent subtraction formula. There are a lot of them, but let's begin with this today because we're still starting from the scratch. Now, I need you to understand the third thing you need to know. So number 3 thing you need to know is that whenever you are proving trig identities and you have tan, it is always better to convert your tan to sine and cosine. Okay, so sine and cosine helps you simplify your identity or the expression and arrive at the desired result. For example, let's say I want to prove that 1 plus tan squared x is equal to secant squared x, right? I am going to rewrite this tan squared x here with sine over cosine. Why? Because tan x, as you've seen, is equal to sine over cosine, right? So wherever I see tan, I'm going to replace it with sine over cosine. And from there, I can go ahead and simplify. For this one right here, we have a cotangent squared x, right? Now, this cotangent squared x can be written as cosine over sine. Why? It is always easier to work with sine and cosine than with these ones you see here. Cosecant, secant, cotangent, and every other one. But if you have sine and cosine, it makes your job very easier or very easy. Now, that's how it's going to be. Even for this last one here, if I want to prove this identity, I'm also going to rewrite the cotangent and the tangent into their respective values or equivalents in sine and cosine. That is how to do it. It is no magic work. It's all about hard work, consistency, and practice. Now, one other thing that you need to know is that if you have a fraction, right? For example, here we have a fraction, okay? We have a fraction. So always get a common denominator whenever you're given a fraction. Don't get stuck. Get a common denominator for the fraction and then do possible replacements, if any, okay? So that's how we're going to do it. Whenever you have a fraction, don't get stuck. Don't get lost. Just get a common denominator, and then from there, you can work your way out. Now, let me take you through these 3 problems to check for comprehension and solidify our learning. So, problem 1 says if you have 1 plus tan squared x, this is equal to secant squared x. Yes, this is a true mathematical statement, but how do we prove it? Well, like I said, remember, it is always easier to work with sine and cosine than tan, cotangent, cosecant, or whatever. And you should also try to start proving from the more complicated part. For example, if you look at this equation right here, you discover that the left-hand side is more complicated than the right, okay? So begin from the more complicated part. Ignore the simpler part. Why? Because it is easier to to break a mountain than to erect a new one, right? That's how it works. Now, let's go ahead and prove. So I would say proof. Left hand side to indicate I'm starting from my left hand side, and I'm going to copy everything down. I have 1 plus tan squared x. Okay, now what do we do? Remember I told you if you have a tan, okay, rewrite that tan into cosine and sine. And if we go backwards, we've seen that whenever we have a tan x, it's equal to sine x over cos x. So I'm going to replace the tan with sine x over cos x. Therefore, we shall now have 1 plus, okay, sine x over cos x. Remember that they are squared, right? So you also have to square its equivalents. We are trying to prove that the left-hand side is equal to secant squared x. So So I'll walk you through. Please be patient as we do this step by step. Now let's distribute. This 2 has to go to the sine. It also has to go to the cos. Okay, so this is now going to be equal to 1 plus sine squared x. So we don't say sine x squared. No, it's sine squared x. Okay, not sine x squared. All over cos squared x. Have you seen we've converted the tan into sine and cosine, and we've distributed the power across everything inside the bracket. Now, what do we do? Remember I said, whenever you have a fraction, combine them into a single fraction, okay? Before you go ahead and simplify. Now, this can be written as 1 over 1. Remember that 1 over 1 is still the same. So what do you do? How do you combine this? You are going to multiply everything on the left. This is your left-hand side. Everything on the left by the denominator of the right. Both the top and the bottom by the denominator of the right. And everything on the right, both the top and the bottom as well, by the denominator of the left. Okay? That's how to combine them as a single fraction. Alternatively, you can also get the common denominator by multiplying the two of them. You can say cos squared x times 1 gives you cos squared x. So let's use this method. Here we have cos squared x times 1 will give you cos squared x, right? Now we divide. Cos squared x divided by 1 will give you cos squared x, right? Now, once you do the division, you multiply whatever you get by what is on top. So we say cos squared x times 1 gives you a cos squared x as well. Now, cos squared x times 1 gives you cos squared x, okay? You have your plus. Now, next up, you divide again. Cos squared x divided by cos squared x gives you a 1, right? Since they're the same, it's like 2 divided by 2 gives you a 1. In the same way, cos squared x divided by cos squared x gives you a 1. Now, that same 1 times sine squared x gives you sine squared x. Now, we have combined them. So what we're going to, I'm going to rearrange this. Remember that addition is commutative. It doesn't matter whether you say 2 plus 1 or 1 plus 2. Okay, I'm going to rewrite this right now, and it's going to be sine squared x plus cos squared x all over cos squared x. Now, let's go back to our identities. If you remember, we said that whenever or wherever you see sine squared x plus cos squared x, you replace it with a 1, right? Now, we have also seen the same here now. Have you seen? We have a sine squared x plus cos squared x. So I would say, recall, sine squared x plus cos squared x is equal to 1, right? So I'm going to replace the numerator with a 1. Therefore, we shall have 1 over cos squared x. Now, at this point, it's easy to get confused, right? But you have to apply a little bit of algebra here, right? If you have 1 over 2 of this, okay? Since this one is at the denominator, we can write this as this. We have 1 over cos x times 1 over cos x. So we have not changed anything. I only split them into 2. So you must know how to do this. It's very important in proving trig identities. So 1 times, if you multiply across, 1 times 1 gives you a 1. Now cos x times cos x gives you cos squared x, right? Just like if you have 2x times 2x gives you, let's say 4x squared, something like that. So these are the same. It also gives you the same expression back. Now, let's now check. Let's go back to our identities and check if there is an identity that looks like 1 over cos x. So if we go back here to our reciprocal, right, identities, what do we have? We have that if you have 1 over cos x, as we've seen here, it's equal to what? Secant x. So wherever we see 1 over cos x, we replace it with a secant x. All right? That's what we're going to do right now. Now let's do that. So I would say, recall that 1 over cos x is equal to secant x, right? So this implies that wherever I see 1 over cos x, I'm going to replace it with a secant x. Hence, since there are this is 1, this is 2, we now say secant x times secant x, right? Now, secant x times secant x is equal to secant squared x. And let's check if we've arrived at the solution. Yeah, they said we should prove that 1 plus tan squared x is equal to secant squared x. Have you seen? So we have manipulated and we have arrived at this solution, which I have here. Have you seen? So secant x times secant x is secant squared x. It was pretty easy to understand. So this is how you are going to be doing this anytime you are given a problem in this very form. So make sure you rewrite everything into sine and cosine if possible, because it's always easier to work with sine and cosine than with tan, cotangent, cosecant, or secant. Now we're done with the first one, okay? So I would want you to try the second one, and let's see how far you can go with it using the same method that I taught you. So all you're going to do right now is to rewrite this cotangent squared x into cosine over sine. Because if we look at this, cotangent is equal to cos x over sine x. So rewrite it and then go ahead to do exactly what I did. You will arrive at the same solution. Now, let's solve this one together. This one looks a little bit complicated and different from what we've been doing, but trust me, we can also do this together, okay? So use this method I'm showing you today. It's always going to work. Like I said, if you're given cotangent and tangent, rewrite them into sine and cosine because it is the easiest way. Don't start converting your cotangent into secant or cosecant. No, don't do that. Always work with sine and cosine if possible. Rewrite everything into sine and cosine because they are like the bricks that help build these trig identities. And if you don't use them, you might get stuck along the way. That is my little advice for you. Now, let's work out this. Here we have, this is our number 3 question. So it says 1 plus cotangent theta over tan theta over tan theta is equal to cosecant squared theta, right? So this is equal to CSC squared theta. Now, like I said, always begin with the more complicated part. So I'm going to begin from the left, or with the left proof, left-hand side to indicate I'm starting from the left-hand side. And I'm going to copy it down as 1 plus cotangent theta all over tan theta. Okay? Now, like I said, whenever you have an expression, a trig expression that comes in fraction form, always get a common denominator. All right? Don't start substituting or changing because you might end up getting stuck. Get the common denominator and then you can go ahead and substitute. Now here we have a 1, right? Plus, okay, let me write this as 1 over 1. You know that this can be written as 1 over 1, right? Okay, good. So here now, what do we do? Using the same method I showed you, we get the common denominator. Here, we say 1 times tan theta gives you tan theta. Now you divide tan theta divided by 1 gives you a tan. Now tan theta times 1 is tan theta, right? Then you bring down your plus. So the next one here is tan theta divided by tan theta will give you a 1. 1 times cotangent theta would give you cotangent theta, right? Okay, good. Now we can go ahead. Remember, we're trying to show or to arrive at this solution. That is the goal. Okay, now I said, and I repeat, whenever you have a tangent or cotangent, rewrite it into sine and cosine. It's always going to be easier for you to work with. So here we said that tangent, I would say, recall that tan theta is equal to, so for the previous problem, we used x. Now it's now a theta, nothing has changed. We only changed the variable attached to the function. So here we say that tan theta is equal to sine theta over cos theta, right? And then cotangent theta is equal to cos theta over sine theta, right? So this implies that wherever we see tangent, we replace it with this, and wherever we see cotangent, we also do the same with this. Okay, now let's do the replacement. So here we're going to have sine theta over cos theta plus, and the next one we have is cotangent. This now becomes cosine theta over sine theta, all over. Remember, we still have a denominator, and what our denominator is tan theta. So the value of tan theta is also sine theta over cos theta. All right. Now, let's simplify. Like I said earlier, if you have a fraction, combine it into a single fraction, okay? That is what you have to do always. So now we're going to combine the numerator into a single fraction, right? So I will say this is my numerator. Let me now simplify it. Like I said, multiply the two denominators, right? So this is now going to be cos theta times sine theta, okay? Then you draw a line, and then cos times sine will give you cos theta sine theta, right? This is the denominator right now. Now we can now divide and say cos theta sine theta divided by cos theta. If you divide cos and cos, you have a 1 left, right? So if you divide cos theta and sine theta by cos theta, what's left is sine theta, okay? So sine theta times sine theta will give you sine squared theta, okay? Then you bring down your plus. Next up, you divide again cos theta sine theta divided by sine theta, okay? So just like you have cos theta sine theta divided by cos theta, oh sorry, sine theta, right? So we have a sine theta. So the sine and the sine, they cancel out. What remains? Cosine. That's also what we're doing here. So cos theta sine theta divided by sine theta, we have a cos theta. Okay, cos theta sine theta divided by sine theta, you have a cos theta left. Now cos theta times cos theta will give you cos squared theta, right? Now this is our numerator, and we have simplified it. Remember that we also said that wherever you see sine squared theta plus cos squared theta, it's equal to 1, right? Now we're going to replace everything here with a 1. This now becomes 1 all over cos theta sine theta. Okay, so this is the denominator, and I'm going to also write it down here. We have sine theta over cos theta. I know this looks very complicated right now to you, but trust me, you can still learn this gradually. Okay, so this is the denominator as we have right here. All I'm going to do right now is to rewrite this. I'm going to remove this thing from the denominator, and I'll put a division sign. Therefore, we now have 1 over cos theta sine theta, okay, divided by the denominator, which is sine theta over cos theta, right? Now, we are going to take the reciprocal by changing the sign at the center to a multiplication. So we're going to change it from division to multiplication. And when we do that, it also affects the one on the right, always. So this one right here, when you change it to multiplication, the denominator goes to the top, while the numerator comes down. That's how it works. So we say this is equal to 1 over cos theta sine theta times cos theta, we have flipped them now, over sine theta, right? Good. Now let's continue. So if you have something like this one up here and the cos theta, okay, they can cancel out. Okay, so the cos theta and the cos theta, they can cancel out. Yeah, so what remains is now a 1 up here. Okay, so you now have 1 over sine theta from here, and then times 1 over sine theta from here. Okay, so now let's now go back again and check our identities to know if we're to make any replacement right now. Let's go back. So if you look at our, remember we have 1 over sine, right? Good. We have 1 over sine. And we've seen that 1 over sine is equal to cosecant, right? So wherever we see 1 over sine, we simply replace it with a cosecant. That's what we're going to do right now. So we go back and solve. So we say, recall that 1 over sine theta is equal to cosecant theta, right? So this now becomes, we replace the 1 over sine with the cosecant, hence we have cosecant theta times cosecant theta, right? Good. So if you multiply these two together, what do you have? Cosecant theta times cosecant theta would give you cosecant squared theta. Okay, and this is our solution. How am I sure? Because that was what they asked us to prove. Okay, so have you seen cosecant squared theta? And that's the solution. That's how to prove trig identities. So we converted everything into sine and cosine, got a common denominator, combined them into a single fraction, simplified, and rewrote everything using our reciprocal identities, and we arrived at this very solution. So thank you very much for being there. In my next video, I'll show you how to use the sum to product, sum and difference, double angle identities, and half angle formulas to prove other trig identities as well. Thank you so much. If you have any questions, comments, contributions, please reach out to me in the comment section and I'll be right there waiting for you. See you in the next video, and bye.